this lesson we're going to look at 9.3 similar right triangles. We've already talked about similar triangles in the past, but now we're going to be looking at a specific similar triangle that's made out of a right triangle already. So when we're looking at this similar triangles in a right triangle similarity, basically what we have is we're going to have a right triangle. So if you notice, we have like this triangle ABC in this picture. Okay, and it is, oh, I've mixed the letters. And it is a right triangle already. See, this one's going to be the right triangle. And so all you do is you're going to draw down the altitude. And so the altitude here I'm going to put in blue. Okay. The altitude is going to make a right angle with the bottom. And so the triangles that are formed are going to be similar with the large triangle as well. And so if we look at our triangle ABC, and so they have it listed here, we have ABC is similar with all the other ones. Think about like the longest side, the shortest side, all that stuff, and the hypotenuse. So like the hypotenuse of ABC is the length of AB, so that's why AB here is first. Of this triangle in red here, the hypotenuse is AC, that's why AC comes first on that one compared to AB. And the hypotenuse on this one is CB, and so that's why CB comes first. Okay, then we have like either the long leg or the short leg. So on ABC, the long leg would be like our AC. Okay, this would be like our long-legged over here. The long leg on ADC would be like AD, and then the long leg on CDB would be this one here. And so those are all the sides that are going to be similar with each other, and they're going to be in the same position as well. So basically what happens when we're looking at a problem like this, your similar triangles, we're going to have a large triangle, we're going to have a medium triangle, and we're going to have a small triangle. Okay, so our large triangle, if we think about it, and from this diagram, I'm going to draw them all the same way. So I'm going to have my long leg going up and down here, my hypotenuse is going to be on the right side, my short leg on the bottom. Okay, so my large one, my hypotenuse for my large triangle, if I look at just the outside portion here, okay, is going to be RS. So I'd have R to S. My long side, okay, if you notice like the ST here is really short, RT is definitely the longer leg, so that would mean that RT would be here, so I have RST. Then if I look at my medium triangle, okay, my medium one is going to be the one that's on this side here. Okay, so my medium triangle, I'm going to draw it in the same way. Have my right angle. My hypotenuse for this one is going to be RT. My long leg for this one is going to be RU. Okay, so that means U is the one that's on my my right angle, and so RU is going to be here. So this one would be R. And then T is going to be right here on the other side. Then my small triangle, I'm going to draw the same way. Okay, my right angle for it is on U again, so this one will be U. My long side, comparing my legs, is going to be UT, so I'll put T up there. My short side is US, my hypotenuse is TS. Okay, and so if I want to identify my similar triangles, I would need to write them all in the same order. So if I'm going to go from, I'm going to go around this direction when I talk about it. So my first one, I'm going to say triangle RTS would be similar with triangle, going this way again, RUT, and it would be similar with triangle TUS. I want you to notice that UT, like on this edge over here, down here at the bottom, UT isn't necessarily going to be in the same position on different triangles, especially our medium and small triangle. The side they share are actually, obviously they're congruent in lengths, but they're similar to different sides of the triangle. Because they're congruent, it's the short side on the medium triangle, it's the long side on the small triangle. And so if we look at this first example, it's going to be important for us to first identify what's similar with it, okay? Once we have our similar triangles, then we can set up our proportions just like we were doing in Chapter 8. Okay, so I'm going to start out this one off the same way. I'm going to start off with trying to find my large triangle, my medium triangle, and my small triangle. Okay, so my large one, I'm going to draw it, my right angle. Okay, so my large triangle on the outside, my right angle is Y. My long side is going to be the YZ, is the longer one, so I'm going to put my Z here at the top, so that leaves X down here. My medium triangle is the one here on the left side. It's not the smallest. So the right angle for that one is down here at the bottom, so that's going to be my W at my right angle. My long side for this one is WZ, and so that leaves Y as the other corner. Y, not X. And then I have my small triangle. Okay, so again, my right angle is going to be my W. My long side for this one is WY, and then that leaves X as my other vertice. So now I have these similar triangles already. So I'm going to plug in my sizes and then I'll be able to solve. So I know ZY up here is 5.5, so anywhere I have ZY I can put 5.5. So that would be here too. I know YX is 3.1, so anywhere I have YX, I'm going to put 3.1. Trying to put it down here. Okay, and then I have ZX is 6.3. And then YW is my H. And I'm going to put in a different letter so you can see it. That's going to be my H right here. And so I need to find the height of the roof. So I need to set up a proportion in order to solve. So if you notice our big triangle, we have everything in this one. We have the hypotenuse, we have the legs, and all three. We have 6.3, 5.5, and 3.1. So I'm going to use that one. So when I look at my small triangle, I have this one side, my hypotenuse side, of 3.1, so that means YX, the hypotenuse there, would be similar to the hypotenuse on my other triangle, so ZX. And then on my little triangle, I'm looking for YW, and YW is on the long side there, so it would be compared to ZY of my big triangle. Okay, so I really don't even need my middle one right now, my medium one. So I'm going to plug in these values. So YX, we have 3.1 over ZX, which is 6.3, is equal to YW, which is our H, or height, over ZY, which is our 5.5. So once we have this proportion, we already know we cross multiply, and then we solve. So when I do 3.1 times 5.5, I get 17.05. And then 6.3 times H, I just get 6.3H. I'm going to divide by 6.3. And so I end up getting my height is 2.71. I'm going to give it 2 decimals. Or everything else is in 1 decimal, so you can just give it 1. So 2.7 meters would be my height. Make sure that you're doing the monitoring progress as you go. Just stop the video, do those problems, and see if you understand before you move on to the next section. Do these videos in small bits. Don't try to just cram it all in and get the notes done. It does no good if you don't understand it. Okay. So as we move on to the next one, geometric mean. Geometric mean is just, like it says, it's two positive numbers. Is the positive number that satisfies this equation. So basically what happens is we get these equations. X squared is equal to a times b, or the same thing is x is equal to square root of a times b. So if I want the geometric mean of two numbers, all I'm going to do is I'm going to multiply them together, and then I'm going to take my square root. Okay, that's what happens. You're going to multiply them and take the square root of those numbers. So in this first problem, we're going to do exactly that. So geometric mean, is equal to the square root of AB. So like if our geometric mean is x, so plugging in for AB, we would have 24 times 48, which gives us the square root of 1152. And so then the square root of 1152, you would need to simplify whichever way works best for you. I've been telling some students in class, if you would rather do a different method, I can show you the tree method. But the method that I showed you on the video, 1152 can break down into 576 times the square root of 2. And then the square root of 576 is just 24. So I'd have 24 square roots of 2 would be the geometric mean of those two numbers. So basically the reason that they show us geometric mean in this section is because of these similar triangles. The similar triangle that we form by doing our right triangle, basically in order to find missing parts from it, we can use geometric mean. Whenever we use these same sides, so like how we said earlier, like CD in this case, is going to be on both the medium and it's going to be on our small triangle on the bottom here. Okay, but it represents two different sides of similarity. It represents the short side on the medium triangle and the long side on the small triangle. So when that happens, we end up actually multiplying it with itself. So here you can see when we set up proportions, CD gets multiplied with itself and it's equal to the other two multiplied together. And so this format is geometric mean. Okay. And so what they're going to show you in these theorems is we can have geometric mean altitude theorem. And so this one is telling us whenever we are looking at the altitude of our right triangle, the big right triangle, then we can use geometric mean if we know the two parts of the other parts. So like if this is our altitude CD, if we know those two base parts of our triangle where it's broken into, we can set up this geometric mean where the altitude squared is equal to those two parts multiplied. Then we also have geometric mean leg theorem, in which if we are missing we're looking at our legs of our triangle, it's going to be the closest portion of it multiplied with the whole thing. Okay, so I define like CB here. It's going to be the closest portion of the bottom legs there compared to multiplied with the whole thing. Okay, you can use these geometric means if they make sense to you. Okay, then there's some different methods if you would like to see some of them where we can plug in different variables and I can give you all these sorts of formulas. But the main thing is that if you know how to do similar triangles, don't complicate it anymore and just keep using your similar triangles and just set up your proportions like we've already done. And so this first problem A, I'm going to set it up using geometric mean. If you would like to set up the triangles, the similar triangles, it will work the same. So this one, we have an altitude here in the middle, and then we have our two parts, okay, on this other side of the big triangle. So this geometric mean is the altitude squared is equal to the two parts multiplied together. So x squared would equal 6 times 3 gives me 18. I take the square root of both sides. 18 is not a perfect square, so I would have to break it up. So I could do the square root of 9 times the square root of 2. Square root of 9 gives me 3, so I can do 3 square roots of 2. Again, if you did this by setting up proportions, you would be able to do like your long side of your small triangle over your long side of your medium triangle would equal your short side of your little triangle compared to your short side. When you cross multiply, it's the same setup. We would have gotten x squared equals 6 times 3. Okay, if you need to set it up like that first, you get to the same answer. In B, we have not the altitude, but we have one of the legs of the big triangle, and then we have the two parts again over there. So this one is equal to this leg of the big triangle, y squared. We're going to do that leg squared is equal to the closest part. So the closest part is my 2 times the whole thing. So not just 5, but 2 plus 5, the whole length here. 2 plus 5 gives us 7, so it would be 2 times 7. So we would get y squared is equal to 14. To get y by itself, I take the square root, and so I would get y is equal to the square root of 14. I can't simplify that any further, so that would be my answer. Okay, this last problem, example 5, we're using indirect measurement. And so we're going to use this triangle that we just figured out how to do our geometric mean, or like I said, you can do the similar triangles. Now in this problem, I mean, would this necessarily be the best form of indirect measurement? Maybe not. There's better ways to do this problem. But in this case, this is how they did it. So it says that they have this triangle, they use this cardboard box. So basically, if we just look at this picture, we have our triangle already drawn out. Okay? So we have our altitude of our right triangle, the big triangle, and then we have both parts. Okay, we have one that we're looking for, and we have the other one. So remember, our altitude one is that we do that altitude squared is equal to the other two multiplied together. So if I were to write this out, I would do 8.5 squared is equal to, like I said, the other two parts multiplied. So I would do 5w. And so when I do 8.5 squared, I get 72.25 is equal to 5w. I divide by 5 on both sides. And so I'm going to get that w is equal to about 14.45, and they measured it in feet. So this is the height of w, but notice what they asked in our question. They said approximate the height of the gym wall. The gym wall is made up of that whole side, so I'm going to have to do my w plus my 5 feet. Okay, so if I add 5 down here to this, that means I'm going to end up getting 19.45 feet for the height of the gym wall.